Welcome to Digital Ship VPO webinar. We are kicking off this week with a case study of Dorian LPG and vessel performance solutions on transforming performance data into decision support. We have 4 guest speakers today, 2 from Dorian LPG, which is Grzegorz Zbos, Fleet Performance Manager, and Peter Hadjipateras, Corporate Development Manager. Also on Vessel Performance Solutions side, we have Irini Arvanitaki, Vessel Performance Manager, and Jakov Bus Petersen, who is a naval architect, also the co-founder of Vessel Performance Solutions. Vessel Performance Solutions is also sponsoring this webinar. We're thankful for this. We'll have plenty of time for questions after the speakers talk, so please send them anytime to the Q&A box. And we are starting with Carl Jeffrey, founding editor of Digital Ship, who will lead us into the discussion.
Okay, so what's different about the story you're going to hear today, in my opinion, is a sort of different approach to digital technology. So we've done a few webinars now on vessel performance, and the software there is sort of like a black box. So you buy the software and the software gives you the answers, and that may well be what you want as a shipping company, but you may also want something different. So that's what we're going to show today. So Dorian LPG is going to show how they use it. So it's built around a data platform rather than a black box. So you can see data coming in from different places, and you get tools which shipping company staff can use themselves to work with and show the data the way they want to. So they get much more power and control, and they decide themselves what they want to do with the data, what visualizations they want to make, what questions they want to answer, and what understanding they want to have. So this might also give you more flexibility if you want to create new tools. For example, if there's a new reporting requirement, you can build it yourself. And we're not talking about a single piece of software. As you're going to see, there's lots of different software components which come together and integrate it all and visualize it. But perhaps the most critical piece of software is the one that sits in the middle, which sort of runs the platform, which today that's made by Vessel Performance Solutions of Copenhagen, and we're going to hear more about that. So the first speaker is going to be Irini Arvanitaki, who's a Vessel Performance Manager with VPS. So she's going to explain the philosophy of their data platform solutions called VESPER, how it enhances transparency and the objectivity of the fleet performance. Irini is a former Fleet Energy Efficiency Manager with Maersk Supply Service, and she's got a master's in naval architecture. Then we're going to hear from 2 staff at Dorian LPG, also in Copenhagen, Grzegorz Zbos, who's the Fleet Performance Manager, and Peter Hadjipateras, who's the Corporate Development Manager. They're going to show how they use the data and how they make real operational decisions with it, like the best time to do hull and propeller polishing, what paint they should use, and when to dry dock. And they'll show how the architecture looks like from their perspective. Dorian LPG is the operator of 2 very large gas carriers. And finally, we're going to hear from Jakov Bus Petersen, who's the co-founder of VPS and also naval architect and the former head of vessel performance with Maersk Maritime Technology. He's going to talk about the collaborative work which was involved in building VESPER, which was done in partnership with the shipping companies Torm, Lauritsen, Hapag-Lloyd, and Danish universities. And I've got a special note for our participants in Greece that Ms. Arvanitaki is going to be moving to Athens in a few days and opening a branch there. So if you're interested, you can go and meet her. So I'd like to invite Irini to give the opening talk. Thank you.
Thank you, Carl. Can you see my screen?
No.
Not yet.
Okay.
Yep.
All right, here we go. Thank you, everyone, and welcome to this webinar. I'm going to start with introduction of Vessel Performance Solutions and our services. For this presentation, we have selected a practical approach. So we'll actually be presenting an example of how you can use our software, VESPER, for decision making. After an introduction about our company and our mission, then we will look together at an example of the worst performing vessel in the fleet. And for this specific vessel, we will be using VESPER Analytics for decision support. Then we will talk about the importance of data quality and how we can manage data quality through VESPER. And then in the last part, I will present the crew feedback application that is used on board by vessel's crew. Vessel Performance Solutions was founded by Jacob Boes Petersen and Christian Bendix Nielsen in 2014 here in Copenhagen. What we do is that we bring consistent insights to our customers for the operational performance of their fleet, to enable decision making, to save fuel, and of course, reduce the CO2 footprint. Our business is growing, and as Carl said, we are starting a branch office in Athens this June. Among others, this is our client base, and you can also see here Dorian LPG, that right after will give a presentation on how they manage vessel performance in their fleet. Today we have more than 1,000 vessels in our database, and the list is growing. So the process starts from the vessel. We collect data. The data can be either noon reports or automatically collected sensor data if that is available. And then we enrich this information with external information such as weather handcast data, AIS data, etc. All this go into our analytics engine, and from that you can extract performance and trends, among others on hull performance, main engine, auxiliaries. You can check environmental compliance, etc. These results can be used by different stakeholders in a shipping company and make business cases for necessary actions. And in the last part, to close the loop, here represented by the dotted arrow, we have implemented the crew feedback, and I will talk about that in the last part. All right, let's dig into the actual example we have prepared. The most important feature for a performance manager is to be able to assess the performance of all the vessels in the fleet and identify the worst performers that need attention. In this example, for this reason, VESPER has this graph that is added hull resistance percentage as a function of months since dry docking. And in this example, we can see that the vessel AI is the vessel with the highest performance in the fleet, in the area between 35 and 40%. And it's worth looking at it because there's still almost 2 years to go until next dry docking. So let's have a look at the history of hull performance for this vessel. We can see here an overview of the performance since last dry docking, a bit before last dry docking. That was in January 2018. So in VESPER, you can find that the excess consumption before the last dry docking was 18 tons per day. After dry docking, we returned to added resistance 0. That means clean hull, and that's actually expected after a dry docking. And slowly after that, we see that gradually the performance deteriorated until just before the next event, the vessel had reached 6 tons per day excess consumption. A very successful hull cleaning we can see because we returned back to added resistance 0, so clean hull. But this time we see that the degradation was much faster. And in a few months, the excess consumption reached 9 tons per day. Then we had a propeller polish that we see that reduced the level of added resistance, but most importantly, flattened the steep trend of degradation. And if we summarize all the information available, the vessel is an LR2 tanker, consuming approximately 45 tons per day in laden condition. And currently, the vessel is spending $4.6 thousand per day in excess for fuel consumption. The rate level is $60,000 per day. There is still about 2 more years to go until dry docking. In a similar way as the hull performance overview in VESPER, we have main engine performance, auxiliaries and boiler fleet overviews, and then we have checked that this vessel doesn't have any major findings for the period. And then last propeller polishing reduced added resistance a bit, but we know and expect that it will start increasing again. So now what to do? To decide what to do, there are more operational and commercial parameters we should consider, of course. And in any case, this is a company's decision, and Dorian can explain right after how they address these challenges and how they make those decisions. But using VESPER, we can, for different action scenarios, we can make business cases, and we can calculate return of investments and support the process. In the long term, one should also consider the paint application. Here we have an owner that is normally using paint A, and in 2 vessels has also tried paint B. And in the same graph, added resistance percentage versus months dry dock, we can see that the paint B does not seem to perform as good as paint A. Of course, in VESPER, we can dig into details and find out why is that and make sure that this is the case. But anti-fouling system selection is influencing the performance of the vessel for a long-term fixed period, 5 years, and VESPER can give you the information to make well-informed decisions when planning dry dockings. So now we have seen the main feature of VESPER, but it's important to remember that if poor data goes in, then poor data goes out. And in our case, for vessel AI, if we're going to make decisions on hull propeller, hull cleanings and propeller policings, we need to make sure that we can trust the data. Are there inaccuracies? Why and where? So in VESPER, we have a data quality evaluation mechanism, and we actually think that this is one of our strongest benefits. We can have it either on fleet level or on vessel level. Let's see an example of operational data quality report on a fleet level. Here you can see all the warnings in yellow and errors in red in percentage of total reports that have triggered for this fleet. It's interesting to see here that in January 2020, the shipping company launched an initiative to focus on data quality improvement. We can actually see a solid improvement after that. And if we go to a vessel level and we look at our vessel AI, we need to check if there are errors related to added resistance. And then we can see that some have triggered for added resistance, and easily by clicking on it, we could see what errors these are and talk to the vessel. And we always expect to have some errors, especially when it comes to manual reporting. But then it's important to see that the error percentage is low and we can trust the data set for decision making. Last part, crew feedback is a new application that is used by vessel crew and is creating transparency on vessel's performance and of course data quality, as we just discussed. It is a web application, so it's not necessary to install anything on board. And as soon as the vessel has internet access, then they can access the application. What is most important for crew feedback is the vessel doesn't only see their own performance, but they can benchmark their performance against their peers. Here's an example of what we would see if we were on board vessel R. Here we have selected the auxiliary engines, daily consumption and import. Of course, other options are available. And then you can see that on vessel R, we are consuming 0.7 tons per day in excess from the baseline. And also this is the highest of our peers. Based on this information, the engine team could discuss why is that different on our vessel? Is there something we can do about it, and also plan how to do it? So that was a swift presentation of what VESPER can do for you, and of course we don't have time to talk about everything, so have left out environmental compliance, current and future regulations. We have left out charter party voyage analysis. But VESPER is easy to work with. It's very easy to get started with, because we can work with the data that is already available. And we're confident that we can properly assess the data quality. Yeah, and we would very much like to show you the rest benefits of VESPER. So if you're interested, we can have a separate session. Please contact me. Thank you very much.
Oh, thank you, Irene. Okay,
Yeah.
so we're going to stick with Copenhagen, and we're going to hear from two staff from Dorian LPG, which is Grzegorz Zbos, the Fleet Performance Manager, and Peter Hadjipateras, who's the Corporate Development Manager. Just before we start, there was a question from Thomas Tyndall, which somehow got moved into the answered panel of the Q&A, which is a mistake. But don't know if Thomas, if you want to submit it again, or we can. We'll try and cover that. But you can see there's already some questions coming in. We'll take all the questions at the end. But I'd like to invite Grzegorz and Peter to give their talk. Thank you.
Thanks a lot. Wait a moment. Can you see our screen?
Yep.
Can you see our presentation? Sorry, Karen.
Yep. Yes. All fine.
All right. Thanks a lot. So good morning, good afternoon, good evening, everybody. We are broadcasting live from our office in Copenhagen. My name is Grzegorz. I'm a Fleet Performance Manager. And with me is Peter.
Hi, I'm a second member of our performance team here in Copenhagen.
And we want to show you a little bit about how we are performing and maybe how we are doing the day-to-day performance and how we are using the VESPER, the VPS system in our daily deliveries. So just to start from the very beginning, probably all the companies which are which have any performance right now, they are fighting with the same problems as we do. The performance is very noise sensitive. It's sometimes very difficult to say what's happening with the vessel, what's happening with the anti-fouling, what happens with the propeller. It's also very difficult to say what influencing the hull performance, because the operational pattern, how we operate our vessels, influence how the anti-fouling is behaving between the dry docking in the dry docking period. So you need the proper system to tell you the whole story. You need the partners to be clear in their deliveries. That's what we probably always say with Peter, is that we don't need the simple system. There is nothing simple in this what we are doing. There is nothing simple with this what the VPS is doing and delivering to us, but we need the clear answers. That means the clarity is very important for us in their deliveries. Not only the clarity how the system works, also the clarity what is the development status of the system and where the system is going and what we will get in the future from the system as well. And that's probably one side of that's the part of our performance initiatives. The second thing what is really important for us is having the system which gives us a little bit more than just the black box. And something we're throwing in and something going out, and we never have the opportunity to do something with the data. That's why we say that we need the system with the proper mature API and connections, that we can use our BI system also from time to time to do the visualization as we need them. Because sometimes we have a very agile approach to this what we are doing, and we need some kind of visualization on the data. That's very quick questions from the management we have to answer, and that's why we need the data to make the visualization ourselves. If this visualization comes later to the VESPER or to the system, we don't know. Maybe that's something what Irini and Jakobus will consider later as something what will stand the time. Or maybe not. Maybe that's one-time delivery we will have to deliver and maybe forget about it because it's difficult. All right, we are now trying to show you what we are doing, and probably Peter will start from telling something about our company first.
Yeah, so I'll do our standard company spiel here. I'll try to be brief, but at Dorian, Dorian evolved from a Greek company started in 1973 that focused on tankers and always had a deep focus on safety and environmental cleanliness. And then in the early 2000s, 2002, Dorian entered the pressurized LPG space, and then in 2012 entered the VLGC space. And we expanded with a new building fleet of 19 in 2014-15, which brought our total fleet to 22 VLGCs. We have offices, our headquarters is in Stamford. We have a commercial operations office in London and Singapore with our partners Phoenix Tankers, who run the Helios LPG pool with us. And then we have commercial as well and fleet performance here in Copenhagen, and the rest of our management services in Athens. I just mentioned we also operate a VLGC pool with an additional 11 VLGCs in it in partnership with Phoenix Tankers. Right. Here's a nice little video of one of our VLGCs.
All right.
All right, so back to business. So here we have our data web, which we will go through briefly.
Yeah, just briefly to not waste your time on that. That's our general idea how we are treating the data. That means from the left to the right, from gathering point until the delivering some kind of analytics. That's very important for us to have a kind of high level overview from where we are taking the data, how we are treating them, and what we are doing on the end, what we actually have to deliver. And that's a part of our digitalization journey, because we need the high level overview, how we're gonna do this and what is on the right side we have to deliver. So as you can see in the center of the system and kind of brain of the system is the VPS, is the VESPER system, because we need the system to process, validate, create the model, filter the data, and deliver us the analytics. Most of the analytics we have already in the VESPER, but some of the analytics, some of the visualization we need to do in our BI system over here. That's why we need the connection also to the BI to deliver ad hoc analytics, whatever we need. The second thing is, of course, the whole IT thing. That means we need to have the mature IT side, and that's what we are building right now. That we are building the data lake on Azure, just to make the flow possible, just to push the data through the data to the VESPER, to Tableau and other systems we probably will need. Last not least, we have the manual data reporting system, and we are using the VESLink. It is also because we have the pool partners, and actually this is the common denominator, and that's what we can do for all the vessels. That means gather the manual data on old style NUN reports. And right now we are working with Kongsberg. We are joining the Vessel Insight platform, and from our vessel we will take the high frequency sensor data, and we will also push it to the system. We will need also the better overview on the added resistance calculations. Last not least, we are using, of course, the BI system, just to whatever we cannot get very quickly from VESPER, we are able to deliver very quickly from Tableau, having the proper mature API from the VESPER and connection to the system. It's very important for us. So let's start it. We are 8 minutes, so we don't have so much time. It's all starting from the data, and I think this is the most important part usually. And if you guys are from the shipping business, you know how difficult it is to get the proper data and get out the analytics on the data which we are gathering. It's a very noisy system, and this whatever is starting the data gathering, you will get on the end. Irini also was talking about it. Peter, maybe you will talk a little bit about it.
Yeah, I think Carl, you used the word objective in your assessment of VPS's ability to look at the data, and I think that's a great word to use. I think before we moved to partner with VPS, I'd say 2 or 3 years ago, we were spending 75% of our time trying to objectively look at the data and then normalize it in the right way. And 25% of our time taking action on that data. And now it's reversed, and we're probably spending less than 10% of our time combing through the data with the help of the software. So that's great, and that's what you want to get out of a platform. And then we'll go into this in the later slides, but VPS has also helped us tremendously in trying to normalize our sensor data and make that comparable to the manually reported data.
I think data reporting, yes, that's usually it starts already from knowing what was reported, which vessels are reporting, which vessels are not reporting. We are getting it from Tableau, but that's actually we are feeding data from the VESPER just to know that we have all eggs in the basket. Probably the very good part of that and the huge part of that what we are doing is data validations, of course. And we are using a lot of things from VESPER just to validate the data, just to see if we have all data validated, if we don't have to come back to the vessel, ask them to resend the report and so on. VESPER have a very good validation model, validation platform inside, so we can overview errors, warnings, and we can tell very quickly which part we need to improve and actually in which moment of the reporting we are. What we have, the dashboard. I think it's a great thing also in VESPER. It's actually most of the time opened on my dashboard on my Google Chrome. So we are looking at what's happening and which vessels are making us a problem. Which we have always 5 vessels which are a troublemaker. That's a great knowledge for us, because we have to attack them very quickly, probably. And of course, Evrini was talking about the crew feedback model. Is a big part of our deliveries, because our approach to the data qualities are actually coaching the people. That's why we are doing a lot of job with the crew on board. We are trying to show them what we are doing, how we are doing, and this visibility of the data from the VESPER to the people on board is very important. They have to know what they are doing wrong, what they are doing right, and that gives them also kind of ability to be better very quickly. That's all about the data reporting. We are very tight on the time. Let's come back a little bit to the analytics using the VESPER, and that's a big part of that's what we are doing, and that's the huge part of our deliveries, because we are using the added resistance extensively within the Dorian now, including the pull point calculations when we are using the added resistance to make the bunker adjustment and to deal with the money in the pool. So I just gave you a little bit overview. That's one of our vessels, and how hectic is between the dry docking period. And it's very hectic when you look at that like this. It's a lot of influence over here. Sometimes the data quality, sometimes that's the aging of the antifouling or getting it dirty. Sometimes it's the quality of the antifouling and hull cleaning is getting better. The proper visualization of the added resistance through the dry docking period is really important for us, and that's what we are getting from the VESPER, and that's very clear message in which point of the antifouling aging we are right now and what we have to do. There was a question that we should do the hull cleaning before. I would say we should never do the hull cleaning, because that's the paint should do the self-cleaning process, of course. But yes, you are right, and that's why we have this beautiful trend lines which are probability rated. So we can see, actually, we can predict what will be the added resistance in the future, 1, 2, 3 months from right now, and we can make the smart decisions when to do the hull cleaning. And especially for the people who are doing the hull cleaning, you know already that it's very difficult to do the hull cleaning, because of course it's about also having the cargo on board, not having. It's a very difficult arrangement. So sometimes it's a calculation of return of investment, and that's what we have also from the VESPER. And to make the proper decision in the right time, when to do the right hull cleaning, or maybe when to wait for the next round and make it later, because that's maybe more beneficial. Yeah, that's what we are doing.
And our hope is, with our autolog data overlaid, our actionable insights will just become faster and faster.
Quickly over here, vessel performance overview. Irini was describing it already. It's great to know, to see our fleet and where it is, to catch the outliner and to talk with the outliner and on our daily basis to actually talk only about the outliner and leave the vessel which are performing well. That's a great view.
Also, as pool operators, it's allowed us to offer a sort of transparency to our partners that is unique and give them full transparency into the performance of their vessel mid-period and help them mitigate fouling as well.
We'll have very little time, so I will be very quick. And that's what we say, is that we need a system which sharing with us the data, because sometimes we need to do something more about the data that just the black box and get the data and see the data on the user interface. So we are using heavily Tableau BI system just to go through the data and sometimes do the visualization we need locally to present to the management, to pitch for the better quality of anti-fouling systems, to make the points why we need something. And that's why we are using the added resistance data sometimes to do the things like that the hull treatment savings, for example, when we are showing how much we save or how much we lost during the year for the hull cleaning propeller polish initiatives, what we are doing. And that's a great way to make the points that we are actually earning something in the process. That's the return of investment we have to do. The second thing for example, we did with Peter is to looking for the better paints, for the better anti-fouling system. When we use the VESPER data actually to see which paints we have and which paints give the best results during the dry docking period. And we had this result and we could talk with technical about which paint we should use for the next dry docking, because we have the data and we can say actually which paint is the best in this paint, which we have already in our fleet. We are doing something else also, like the aggregation of how much we spend more on the standard paint and how much we can earn on the premium paint. That's whoever doing the talking with the management knows that that's the kind of best thing you can do, show the money on the end of the process. And we are doing much more like we are preparing for 2023 for of course for the new IMO regulations. We are trying to sandbox how our fleet can look in the future and what we have to do. We are run out of the time. We have to summarize it quickly. Crew.
Yeah, I think this infographic just represents kind of our philosophy, where it has to start, performance has to start on board and with the crew, and we're in a new era of total transparency, and that's something we try and portray from the captain and chief engineer level all the way up to senior management and the pool level, and that's something that VPS has really helped us successfully do. Yeah.
IT, that's the heart of the system. Usually, you have to pump the blood of the data through your system, and that's why you need the really strong IT to support you with everything what we are doing, and that's why you need to think about it, and that's like a fundament for your delivery. Core system, that's our VPS, our VESPER, that's kind of brain, and that's what we are doing. When we have a data, when we have a crew, we need a core system to calculate the added resistance and everything around it, and to show us the basics and where we are and what we are doing. BI, we need the agile way of visualizations, something what we cannot get from other way, or maybe that's something which is really ad hoc and we need to deliver from day to day just to make a point about the performance. Last not least, it all accumulate to the IMO requirements which are coming. We need to be prepared for 2023, and that's why we are doing those steps from top to the bottom. It's really important for us. I think that's us.
Wow. Well, thank you very much. Okay. Just a note for the audience, you'll see there's a lot of questions coming through. You can actually upvote people's questions with the thumbs up sign. So I'm not sure we'll have time to answer all the questions, but if you upvote them, then we'll know which ones to focus on first. So finally, we'll stick with Copenhagen. Here's Grzegorz Peterson, the co-founder of VPS, and he's going to talk about the collaborative work involved in making VESPER.
Yes, thank you very much, Carl. You can all hear me?
Yep.
Yeah, good. Yeah, welcome. This is, of course, these webinars. It's a little bit of a tough game of keeping people interested and deliver a lot of stuff, and there's so much you would like to communicate at the same time. You have seen snapshots of how we, of the status of our software as it is right now. But I think what is even more interesting is how, well, that's how we look at it. What is the future going to bring? What are we going to develop to help our clients even further? And that is what I would like to talk about. And even though we say that VESPER is a very good platform, we don't say that we are done, that we cannot improve. We can improve on a lot of points, and there's so much uncertainty in vessel performance still, that there's a lot of stuff that we can work on. So the first thing that I would like to explain is, we have come to some point, but we of course are fully aware that we need to continuously develop and improve our software. Our stakeholders, our clients, they are ship operations, it's ship management, it's chartering in our vessels. So vessel benchmarking is important as well. Asset management, which vessels to get rid of, which vessels to buy, etc. So we need to develop. So that's why we need a roadmap. But of course, that roadmap needs to be designed together with our clients. One of the key elements of this is in any performance system is how accurate are we at modeling the performance of the vessel? Because even though we say we have this added resistance, it doesn't mean that it's 100% perfect. Of course it's not. It all depends on many, many different parameters. The quality of the operational data that comes into the system, the parameters we use for wind and waves, the ocean currents. It's a big discussion. Do we have the ocean currents correct or not? We need the speed through the water to determine the performance of the vessel. The modeling of the vessel itself, and that means speed, power, RPM, and so on, but it's also how we do the corrections for wind and waves. And then, of course, on top of that, you have all the details of the individual voyages. All of these parameters are important in how accurate we can actually deliver the decision support we have in the system. So we need to have a roadmap on how we want to improve on this. And normally the way we do, we are a self-owned company. We don't have investors. We don't have a big capital fund supporting all our developments and so on. So our way of doing progress is to do it through projects. And when I say projects, I mean that we apply for funds with typically Danish Innovation Fund, EU projects, den Danske Maritime Fund and others, to co-sponsor some of the costs of doing the development, and then we seek partners to join in joint industry projects, universities, and so on, to do our developments. I think I would like to mention that the reason why we have been relatively successful in VPS now is that we were able to attract a project called InnoPlus that was done in 2015 to 18, where we got funding from the Danish Innovation Fund, Danish Maritime Fund, and Orient Fund to actually develop you could say, the foundation of the VESPER software. The partners we had there were Tom Lauritsen, Aalborg University, and Force Technology. So that's the way we do our developments. And right now, we have a project called Shipping Lab. It's called Task 1.2, Digital Vessel Operation. And it's an ongoing project started in 2019, and it will last until 2022. And the partners we have in that project is Hapag-Lloyd, Tom Lauritsen, Technical University of Denmark, University of Southern Denmark, CMAC, and of course, Vessel Performance Solutions ourselves. We are the project managers on that. And this project is about digital vessel operation. So it has like 4 legs that we are standing on, or we are trying to develop and evolve in. The digital twin is one of them, reduce the scatter, voids modeling, crew feedback, and advanced diagnostics. And I will try to go a little bit into details on these, each of these items. In the project, we have like 16,000 hours of VPS development, and on top of that, you of course have efforts coming from the universities, CMAC, and the shipping companies as well. And by the way, if there are any shipping companies out there interested in participating, we of course we very much like to discuss that. We definitely invite other shipping companies to participate in this, and it is still possible. The digital twin, it is the reduction of the scatter. So we are working in the project to improve on the mathematical models. So we want to be better at predicting the models and even improving the models as we get more and more data. We are working with added resistance in waves. We are working on wind resistance, engine modeling. We are also working a lot on identifying the best sources of environmental parameters, because I mean, it doesn't matter, even you have the best possible mathematical model of the ship in your system, if the data that you are feeding that model with is not very valuable, then of course you also introduce a lot of uncertainty. So we are looking into what is the quality of the data, the hindcast data, the observation data, and also quality of outer-log data is a part of this as well, on the anemometer side, for example. So all of this we are working on the digital twin, all with the purpose of reducing the scatter that we have in our predictions. On the voyage modeling side, well, basically what is maybe, well, our perception is that in the industry there's a little bit of uncertainty about how to model voyages. There's a lot of, you could say, differences between the predictions and actuals and so on. And we, of course, want to use our digital twin improvements to also improve on voyage simulations. So we are moving into the area of supporting the different processes for voyages. That means chartering, prefixture, fixture, do the yield optimization, what is the correct instruction for the vessel to get the highest profit on each particular voyage, monitoring the voyages, and of course having the system monitor the voyages and only provide alarms and alerts in those cases where action should be taken by operations. And of course the last part, which is maybe the most important part, is that once the voyage has been conducted, then we need to do the analysis to see what we can learn from that voyage so that we can improve future voyage predictions. The crew feedback module is, Irini explained about this, but that is something that was originally then done in the Eco-Prodigy project and EU project that we won. But then we have continued working with that here in Shipping Lab, and it's now being rolled out on more than 100 vessels. And we think this application has a lot of potential going forward, especially as also was said by Peter and Greg, that we need to work together with the crews and we need to understand the same graphics, the same logics and so on in order to improve on the performance on the ships. And then finally, advanced diagnostics. So the system can do a lot of stuff, and there are many graphs and many outputs, and I think it's fair to say that the amount of output sometimes is more than what many clients can actually adapt to completely. So basically we need the system to provide simpler decision support than what we are able to do today. We need to, I think Peter explained it very nicely. Previously, they were spending 80% of the time doing normalization and trying to figure out what the performance was, and then doing performance 20% of the time. And basically, they have been able to revert that. So now they spend 20% of the time to derive, you could say, the performance of the vessel and doing the normalizations and all that. And then they have 80% of the time left to actually do performance. We want to improve that by this advanced diagnostics rules, so that we can come up with, I would say, higher order conclusions that can help and make the performance desk more efficient in what they do on a daily basis. That's the idea of this project. So that's how we do development in vessel performance solutions, and this is, you could say, our roadmap for the next couple of years. And yeah, of course, this roadmap will evolve over time, but yeah, that's how it looks right now. Thank you very much.
Wow, thank you. All right, so I'd like to invite everyone to open the Q&A box on your computer. So you see we've got about 11 questions and we've got about 11 minutes left. So maybe we'll try and do 1 minute for each question. So we've got, starting with Kostas Soretis at the top, we've got 13 upvotes. He's asking about the source of data in your software, maybe for Jakob. I mean, you made it quite clear your system can work with any data. So I don't know how you, do you want to give a sort of general answer to that? Or, and there's also a question from Rajak Sachna. What do you find about drifting sensors? Don't know how you'd like to answer those.
Yeah, but I think the first question is worth, so basically we are interfacing to any kind of noon reporting system or any kind of autolog system that there is out there. We have developed, I think, maybe 20, 30, 40 different interfaces. So basically we take what you have. We have our own data collection as well, of course, but basically it is actually a lot easier if we just adapt to whatever is working in a shipping company today. And it also means that we are very easy to get started with, because we basically start with the data that you already have. So that means we can get to some conclusions very quickly. So that was question number one. The second one was, Carl?
Oh, what do you find about drifting sensors from Rajat Saxon of Epic Gas?
Yeah, but for that we have, you could say, helping trending of relations between different sensors. So basically, when you do vessel performance, the mathematics is an overdetermined system, because you can basically determine the added resistance from many different combinations of sensors that you have on board the vessel. And the trick is to find your way through that bunch of worms, so to say, to point out where you have a problem. And we have different tools for that in VESPER. But it doesn't take away that today the performance desk has to keep an eye on this. But of course, the idea of this advanced diagnostics thing that we are developing is that we will be able to point out directly to the performance desk, what problem do you have on this particular vessel? And we just recently released the first advanced diagnostics rule that can identify problems with one of the most important sensors that you have on board the vessels. So we are moving in that direction with the advanced diagnostics functions.
Okay, so if we go to Dorian for the next two, so Rohit Murugan is asking which methods you use to compute added resistance. I think you kind of covered this. I guess all of them is probably the answer. And then Stabmatis Mavroudis, who's with a Splitoff in the Netherlands, is asking, can you detect 2 to 3 tons a day of excess consumption in the due to fouling? I can't remember. I think it was your case study, but VPS presented it. So I'm not sure if you want to, maybe do you want to start with the first one and then maybe the second one for Grzegorz and Peter?
Yeah, I think yes, we can. Yeah, that's the quick answer for the question. I think there is a lot of things you can still get from the manual reported data, this noon reports, and I think 2-3 tons, when you have the right way to approach the data quality from the noon reports, you can still have it from the system. Probably if you want to go much lower than that you need the sensor data, and that's probably when you have to combine both to have a better quality of the output. But generally speaking, everybody knows, and we are all fighting with that you need somehow to pitch the performance to the people on board, if they understand how important for them is the data quality, and how we can visualize the end of the month performance of the vessel basis on their data they report. That's what happened for us. They changed the way they are reporting the data. They are more kind of aware of that's what's happening in our system, and they understand how important it is to get the counter in the right time, not to make it too long, and so on. There is a lot of coaching with your crew. As we say, the performance is not a one-day job. Is a kind of is the road. You know, we will never wake up one day with the Peter and we will say we are performing well. We have nothing else to do. That's kind of
that'll be the day. That'll be the day.
It's the same probably with the digitalization. It's the same with the sustainability. Is not the value. Is not the kind of value you can define. It's like a limit in the mathematics in the function. Is the road you are going. Is the direction when we are going. And you have to pitch for it, and that's what we mean. You have to coach your crew to be better. You have to pitch for the better understanding of the performance within your company, and so on. That's all together have to work to deliver performance, sustainability, the digitalization. That's the road we are going through.
Yeah, so we're really excited for the onboard crew module. But I think a short answer to that would be we can see 2 to 3 tons overconsumption in 2 weeks with noon data with our current data quality, but we'd like it to be a few days with sensor data or on the day.
I think that's sensor data are kind of clearer in when we are trying to say that something is going wrong on the vessel. From our perspective, from the guys working in the operational or something, when we are trying to talk with the technical or want to say to them, listen to us, something going wrong with the vessel. If you have the overlay of the sensor data, it's much easier message to them, because always when we are showing them the noon data, we will be the question about the data quality and all together. But I think when we have the overlay together, the sensor data, the stable periods together with the noon reports, the message is much clearer, and we can much quicker get the attention of our technical department.
Oh, sounds great. So question for Maria. Should we go to Irene for this one? So I think Maria is the performance manager at Pantheon Tankers in Athens. She's asking about any performance monitoring scheme depends on the data accuracy. How do you ensure that the feed data is accurate? Is it to answer that one?
Yes, so we have the data quality assessment and data quality reports that can be either on a fleet level and a vessel level. We have, you could say, different kind of calculations and validations that could be out of range validations, but most importantly, we have validations that work with a lot of data together and see if the correlation is correct. And then you can, from a fleet level, very easily, you can go on a vessel level, and then you can find all the details for the specific error that triggered. And then if you also have crew feedback, the vessel can have the same view on board, and even without any action, see themselves what is wrong and address this on board.
Oh, okay.
But we can have a look in more detail, Maria, if you would like, and then I can explain more.
Oh, okay. Should we go to Dorian for the next question? So Ranjith Ravindram, I think he's a former chief engineer with Maersk Line, now he's a consultant. So he's asking about integrating operational performance and technical performance. So you're taking issues like fuel quality as well as machine operating conditions. Is this something you do, Grzegorz and Peter?
Well, I think it's a complicated question. It's a complicated answer, of course. I think we are trying to, because it comes to the root cause analysis. Whenever we have a problem with the performance, with the particular vessel, we are going into the details, and so we have to analyze everything what's happened between operational pattern, technical patterns, what's going well, wrong on board the vessel, the quality of the fuels is all together. I think in this moment we are trying to be more wide in our discovery about the vessel. Right now we are doing it like that. So it's about finding the cause of the problem with this.
Yeah, I think VPS has room for speed tests and engine tests, and we'd like to integrate those into our platform. But we do see some development room with regards to fuel quality tests and integrating those in, and further like vibration analysis and things like that in the future. But at this stage, we're more on the performance, and then if we can't figure it out on the platform, we dig deeper and go into our engine monitoring equipment and talk to technical.
Yeah.
Okay, should we stick with Rohit, with the Dorian guys for the Rohit question?
Carl, can I add a little bit to that thing? Because I think it's a very good question. Because vessel performance is a little bit in the middle between, you could say, maintenance, condition-based maintenance, or plant maintenance, and it is towards operations as well. And we will not move into the area of neither condition-based maintenance or plant maintenance, even though hull and propeller performance is condition-based maintenance. That is exactly what it is. But we will interface to systems that do that. That is actually also a part of this shipping lab project, that we will interface to plant maintenance systems. But on the other hand, our voyage module is very much moving into the area of supporting the operations of the vessels. So when you talk about charter parties, when you talk about instructions, that means speed, power, RPM, whatever kind of instruction, optimum yield and so on, we will support that. Well, we are already doing parts of that. We have a cooperation with W&I where we are, you could say, delivering models directly to their route optimization and yield optimization, etc., etc. So we will move more and more into that area of using the refined digital twin model of the ship to support ship operations. Definitely.
Well, can I suggest we extend by 10 minutes? I don't know if everyone's able, since I don't see the participant number dropping off, so I think we're holding the audience quite well. Is that okay with it, Dorian? Okay, so I've lost my track of questions now. Yeah, there's a question from Rohith Murugan about speed recommendations, so you can get that from the data or from the weather routing. You haven't mentioned weather routing. Should we go to the Dorian guys? Do you want to give some comment on that? How which is easier for crew to work with, the weather routing or the available data, or I guess it's just different things they put together, is it?
I think we're very excited for the days for when it's all combined. But at the moment, I think we are trying to work with our crews to combine it for them. So we look at the optimal routes and we're trying to give them the most up-to-date speed tables. The weather providers trying to give the weather providers the most up-to-date speed tables from VPS and things like that. Yeah, but it is a challenge, I think, on board right now to look at both these tools.
Yeah. I think the integration is the direction when the kind of digitalization will take us. And I hope for it, because the integration of the system is necessary. But already VESPER is doing it. Jakob, you may talk about this, the integration of the fuel tables and so on. It's very important, like the integration, that we can integrate the fuel tables, for example, from the VESPER system into the IMO system. So it's such integrations, and it can be done by the API connections. It's very important in the road going ahead, and I think that's the direction the whole industry will go. As we talked before, it's not about the standardization. I think it's about the proper connections between the APIs, and that's where we should go, and that's what we are looking for also. And that's why we have the spaghetti diagram, the Sankey diagram, because that's how we want to integrate the system. We want to share the data between. That's what is important here, to post it somewhere where it may be important for giving us a more analytics from another system as well. It's also possible. Integration, yes.
Yeah. It's also what we believe in. The future of digitalization is not that you will have one system that solves all your problems. The future of digitalization in our book is that you will have different systems that are, you could say, very good in each of their areas, but then they exchange, you could say, the high quality information to the right platform so that they can be further utilized. So this example of merging up with IMOS with the updated, calibrated speed and consumption tables is a very, very good example of that. Another example is that we have, for example, interfacing to weather routing companies, again, where they are using the refined digital twins. And again, as I said, we have interfaces to weather routing companies, but first of all, we have a cooperation, official cooperation also with W&I, where that interfacing is going on as we speak with some of our shared clients. So we believe APIs and sharing of, you could say, high quality information between different platforms, that will be the future of our world going forward, at least. Yeah.
Okay, so we've got two big questions about charterers. I'm not sure who's best to take these. So Evan McGrath is asking, will charterers give you a better day rate, so having better performance? And Costas is asking, what do you do when the charterer is already dictating what bunker quality and routing and other factors you take? I don't know. You probably both have interesting perspectives on this question. I don't know. Maybe would you both like to start with Jakob and then the Dorian guys? Do you think?
I will try and do it short. Basically, we do support pools in VESPER, so that we have 2 different clients that are actually using our pool system to distribute, you could say, vessel efficiency pool points between the members of the pool. At the same time, we also have a charter module which compares the ship's performance with the charter parties. Not, you could say, we of course have the common one where you compare by the rules, good weather, averaging good weather and all that. But at the same time, we also have another evaluation that actually evaluates the vessel's actual performance with the expected performance of what I would say the digital twin of the charter party vessel, so to say. So we actually do evaluations of charter parties, you could say, daily per vessel. And our clients can see that. And that's, of course, both interesting if you're chartering out a vessel. Is my vessel meeting the charter party that I have promised? Or it's interesting if you are chartering in a vessel, does this vessel actually meet what they have promised? It's interesting from both sides. And again, our platform provides the transparency that actually reveals whether that is correct or not. So that's the way we work with charter parties and pools, you could say.
Yeah, Grzegorz and Peter, do you want to have a go at the relationship with
Yeah.
charterers?
Sure, I think Jakob summed it up very well, and we're using it in both ways. At Dorian, we use the charter party compliance module for our own time charter in ships and for our time charter out ships, and then we use the bunker adjustment and performance trends modules for our pool performance needs. And it was not difficult for us to transition from another third-party source to VPS for performance because of the transparency and the academic structure of the platform. It was quite easy to sell to the pool board.
Okay, should we go to Nicolaus's question? So he's asking if you can isolate the impact of one specific issue, like a MUIS stuck on performance. I think you can do all kinds of clever stuff for your Tableau stuff, Grzegorz and Peter. So I guess the answer is you can. I guess that's what you can do with a platform, which you can't necessarily do with other software.
I think it depends on the graduality. That means how many percentage it will improve the performance. Because if it's improving the performance less than 1%, probably if we are using only the noon report data, manual reporting data, it's we are below the limit. And MUIS DAC, actually, it's already probably like 3 to 5%, something like that. And I'm pretty sure the MUIS DAC we can already see on the platform. But also we have to say, installing the MUIS DAC, we will have to talk with Jakob, with Irini to also reshape our Crowley models, to not see it as a better performance, but maybe included in the baseline, such that we know that's it. So I think it depends how big impact it is on the performance and what you have a data source to calculate. But the way the added resistance is calculated using the Heindikas data, using this big filtration and validations modeling, you have. That's what we are doing. We are not using 100% of data to calculate the performance. We have a heavy validation and filtration functionality in VESPER, and we are using only the reports which give us a clear message. And it's also about the sensor when we are using the stable periods. We don't need to use everything what we are getting. We need at least some quantity of data to push it through the added resistance and to have the overview. And that's what we are doing. And that's according to ISO, how we are doing the added resistance calculation. So yeah, I'm not sure if I answered the question, but that's it.
Oh, so it's great. So I'm ready to answer Theodore Ioanou's question. Maybe this is for Irini. So I think he's a Group Technical Superintendent at Burner Shorter Ship Management in Athens. He's got some very specific questions. What do you take into consideration for judging paint efficiency? And do you give automated diagnosis for hull, propeller, and machinery equipment? I think the answer to the second one is yes, because you showed it, I think, in your talk. But and Thomas Tyndall is also asking to talk about your presentation, Irini. Why do you call it a successful hull cleaning when what you're actually saying is that the hull was very foul to begin with? I think that's what Thomas is saying. Is that too much to have a go at?
so VESPER could be used before the event to decide on the event. So now we saw what has already happened, but the intention is to use it to predict what is going to happen and take actions before the degradation steep is too steep, and then it's too late.
Yeah, but I think that answers the question. I think Thomas's remark is, of course, absolutely right, but there can be many reasons why you have a poor performance of a vessel, and there can be this thing that operationally it has simply not been possible to arrange a hull cleaning or a propeller polish because the vessel was simply too busy, and when it was in a harbor where it was possible, then it was not allowed, etc., etc., etc. There can be many reasons why you end up. But the point is, you will always have a worst vessel in the fleet.
Yeah.
That's kind of, no matter if you're fixed the worst vessel, then it's just another vessel that will be the worst vessel. That's how it is. That's how we look at things. Fix the worst things first, and then take the next worst things.
Oh, so next two for Dorian guys. So Andreas Frangos from Sovcomflot. So he's asking, what measures do you take when you know there's a vessel underperforming, so you don't get a claim from your charterers? And then I guess related, Hiro Yoshida is asking, do you have an alarm system on board which warns the crew if something's going wrong? I suppose the question is really, what do you do when you do you get big red flashing lights on your screen, or do you it's not so time sensitive as that, is it?
Yeah, you go.
Go ahead.
I think there are two parts of it. First of all, if the crew can be notified if something's going wrong on board, I will say it's not like that also they will find out one day that the vessel is performing very bad. If it happens from day to day that the vessel is falling down in the performance like that, that's what I would be really careful, because that's something really more than the hull fouling or something like that. The hull fouling happens or not happen because that depends on the operational pattern, on the quality of the painting, the preparation. That's a lot of probably the magic in how the anti-fouling works and how it doesn't suddenly, because we have even the cases when the same anti-fouling is not working the same way for the two vessels. So it's very complicated process. And when we are looking at the vessel performance, we are kind of looking backward, because that's the statistical method to see how it was performing before and where it is going actually. So and doing the decisions about the cleaning, not cleaning, and about that's also the answer for the previous question. That's the strictly operational chartering and financial decision if we want to clean the vessel in this moment or not, or we look at the trend line and we can predict, for example, in the next 2 months what will be the added resistance, and we can calculate how much money it will overconsume. And that's what we are telling. That's return of investment is ongoing stuff every day. We have to make the smart decision basis on the hull condition, how we can see it today, basis on that's what's happening from the last 3, 6, 12 months, and how we will predict it going forward, and how much money is that in the going forward, and we should do something or not. Of course, we don't want to do anything. That's what I'm saying. Also, I think that the previous questions, I understand you very well when you say that we shouldn't do that it's too late. Yes, it is, but that's very complicated way of how the anti-fouling is behaving with all this stuff regarding the biocides, blockages, and so on. Even the good anti-fouling cannot perform well in some circumstances, and that's our decisions here with Peter to make it, to calculate how much is this overconsuming, and what we should do in the next month, or maybe tomorrow, because that's something what we can do from day to day as well.
And I mean, within a specific charter party, it's usually more difficult, but we are seeing charters becoming more flexible and more concerned with overconsumption. And especially if you write it in terms of emissions, their concern goes up even more. So we're starting to introduce clauses for, steaming after a certain amount of idle days and things like that. And then maybe you can manage your RPMs within the charter party terms until you find a safe port to clean. Things like that are just practical things that we're doing with our charters to manage consumptions.
I think the change is coming because actually the cargo owners or cargo providers, that's actually when the change in performance happen, when they step into the process of getting the better vessel, less CO2 emission and less consumption, and they allows us for doing something with the hull cleaning and so on. And it's happening. If you see on the last, I think, 100 list of from Lloyd, influential people from Lloyd, on the sixth place, I think is Trafigura. It's a big change, I think, in the whole industry, that also the cargo players are stepping into the talking about how to perform better.
Carbon credit trading.
Yes, all those initiatives will change the way we are delivering also the performance from our side, or maybe not only performance, like a sustainability as a whole, you know, a whole kind of holistic approach to the whole delivery. We are delivering not just the nautical miles. That's what we are doing. We are a company. We are producing nautical miles for our vessels. So that's very important that also the party which is trusting us with the cargo step in the process and try to help us to deliver it cleaner, better, and I don't know. But it's happening. We are start talking right now. It's very important for us.
Oh, that's great. Well, we're coming to the end now. Maybe I'll just invite Jakob. There's a lot of very short questions on here. Integrating maneuvering systems with vessel performance. What protocol for digital twin? I thought maybe if we invite Jakob to maybe take a few of these in the last couple of minutes. A vessel owners ready for auto logging systems. Can you distinguish a biofueling trend from drifting sensors? I guess you can read them as well as I can.
I can read them and then I will go through them very quick. I think I can answer the first question. Dorian, how big is your performance team? I think you're looking at them, right? Yes. I think the digital twin, I think the protocol for developing the digital twin is a little bit of our company secret. I have been doing mathematical models of ship for 35 years, and I'm not going to reveal all the nitty-gritty secrets of that. But let's just say that it's built on a lot of experience within naval architecture, first principles, and so on. Integration with a maneuvering system for shorter voyages, that would be interesting. But I think in general, the system is designed for the deep sea voyages. We are looking at performance from an overall perspective. But I will not rule out that we one day will see an integration of maneuvering models and performance models, because basically it's the same. At the end of the day, it is the same. Previously, I used to be a maneuvering expert actually when I worked at Force Technology. So I know. Some owners are ready to invest in auto-logging systems. Yes, absolutely. But we are saying that's not the first thing you should do. You should start doing performance monitoring using noon reports and then get the most out of that before you start investing in auto-logging system. Nevertheless, we are integrating with all of our clients have auto-logging, and we are integrating more and more, and it is the future, no doubt of that. The distinguish between biofouling and risk of drifting sensors, well, that's a little bit the same, a little bit of company secrets how we do that, but basically it's with this, you could say, philosophy that vessel performance is determined by an overdetermined systems, and if you have contradicting results, well, then you know something is wrong, and then you have to figure out what's the problem. Again, our ambition is that we, with this advanced diagnostics, will be able to tell you exactly what is the problem on that particular ship. So we will be able to identify which sensor is it that is off in the future. That's our ambition. Hardware installations. Well, yes, hardware. I would say no, it's not impossible to bridge this gap without IoT. IoT is to get the best possible data from the best possible source in the easiest possible way. That is IoT. And if you rely on noon data on board a vessel with lousy sensors, no electronics and so on, then we will be kind of stuck to that situation forever. IoT is definitely a way forward. AIS combined with hindcast is, of course, a beautiful, beautiful example of that. We can get the environmental impact of wind, waves, and currents on the ship over a total noon report, so we don't need the weather reporting from the vessel at all anymore. It's actually not part of the analysis for almost all of our clients. We are using AIS and hindcast weather in that situation. Charter party compliance. Yeah, we can do both. We can do weather provider, we can do observations, we can do 50-50, whatever is defined in the charter party, that's what we do. So we can basically, yeah, deal with whatever weather information we have available. I think that's it very quickly.
Oh, well, that's fantastic. Well, thank you very much, everyone. I think that's the biggest audience we've ever had in a Digital Ship webinar. I shall pass back to Vida for the closing words. Thank you.
Thank you for sparing this hour with us. We managed to pack much in-depth advice on how to transform performance data into decision support and answer so many of your questions. The video recording will be placed on YouTube for your review. And just an update, on this Thursday, we are discussing vessel performance management for big fleets with guest speakers from BSM and Columbia. Sign up if you haven't already. Thanks for spending this hour with Digital Ship. We are signing off until this Thursday. Goodbye.
Yep.
Bye-bye.
Thank you. Bye-bye.